So what is the geometric probability? The geometric probability distribution is a probability distribution we use to find the probability of an outcome when it satisfies these conditions. The first condition is when each trial only has two possible outcomes. And probability of two outcomes are constant each trial. Number 3 is that they're independent, and number 4 is that we continue experiment until success is obtained. Now, main difference from hypergeometric distribution, which you can check out in the previous video, is this, that the probability of outcome are constant each trial. But as for the hypergeometric, the probabilities change each trial. Now, the formula for this is the probability that x equals to obtaining a success in the nth trial. First success in the nth trial is equal to p 1 minus p power of n minus 1, and where p is the probability of success. So basically you get the probability of success multiply the probability of failure power to the number of trials minus 1. And then of course we also have the formula for the mean for a geometric probability distribution, also known as the expected value of x, equal to 1 divided by the probability of success. And our variance, also denoted as sigma squared, is equal to the probability of failure divided by probability of success squared. Moving on to an example question, right? Now, the coin is tossed. Find the probability of getting the first hit on the third toss. That means when we toss a coin, there are only two outcomes, and the probability stays constant, right? It's always a 50-50 for a fair coin, right? Now, we want to find the probability of getting our first hit on the third toss. This means the probability that our x equal to 3, that we get our first success on the third toss, is equal to p 1 minus p power of n minus 1. And this means that our probability of success, in this case for hit, equal to 0.50, right? So we get 0.5, 1 minus 0.5, power of number of trials 3 minus 1, 0.5, 1 minus 0.5, power of 2. What we will get? We will get 1 over 8, also equivalent to 0.125. And that is our probability of getting our first hit on the third toss. Right, moving on. More complicated question. Right, on a particular production line, the probability that item is faulty is 0.08. In a quality control test, items are selected at random from the production line. It's assumed that the quality of an item is independent of that of the other item. Right? A, find the probability that the first faulty item does not occur in the first 5 selected, and 2, occurs in a fewer than 5 selections. Alright, so we already know, in this case, we want to satisfy the condition. There are only 2 outcomes, right? Either you're faulty or not faulty. And faulty, probability P, the probability of this is equal to 0.08 as stated here. Right? And the probability that P is not faulty is 1 minus 0.08, which is 0.92. Right? Now, we also know that independent as stated here, and of course constant. The probabilities remain constant, right? Now we want to find for A where we want to find the probability that the first faulty item does not occur in the first 6 selected A1. So we want to find the probability that it does not occur in the first 6 selected. That means more than 6, right? More than 6. That means it's also equivalent probability of 1 minus probability of x less than or equal to 6. And this means that 1 minus probability that x equals 1 onward and minus all the way up to minus probability x equal to 6, and this can be simplified all the way up to, to 1 by 1. And you will minus all the way up to 0.08, 1 minus 0.08 to the 6th trial, which is 6 minus 1. And the answer you will get is, after typing it in the calculator, 0.6064. And for 2, occurs in fewer than 5 selections. So that means probability that x occurs in fewer than 5. Less than 5, it means the probability of x equal to 1 plus x equals to 2 plus x equals to 3 onward, plus x equal to 4. And it means that you can take 0.08, 1 minus 0.08, 1 minus 1 plus 0.08, 1 minus 0.08, 2 minus 1, all the way up to 0.08, 1 minus 0.08, 4 minus 1. And you will get the answer 0.2836. And that is your final answer. Now, for the last question, when I make a telephone call to an office, the probability of not getting through is 0.45. If I do not get through, then I try again later. That means the experiment always repeats, right? Now, let x denote the number of attempts I have to try in order to get through. Hence, calculate the probability that x is more than or equal to 4, and the expected value of x and the variance. So there are only 2 probabilities, that we get through or we fail. Probability of get through is 1 minus 0.45, which is equal to 0.55. Probability of fail is 0.45, as stated in here, right? The question, right? 0.45. Now, we want to calculate probability that x more than or equal to 4. That means we take 4 or more times for the call to finally get through. This means 1 minus probability of x is less than 4, right? And this means that we take 1 minus probability of x equals 1 minus probability x equals to minus probability of x equal to 3. This means that 1 minus 0. Now remember our probability of success here of getting through, right, is actually 0.55, right? We want to find the success that we finally get through. The probability they gave us is 0.45 is not getting through. So we make sure we choose 0.55. Then 1 minus 0.45, 55. 1 minus 1 minus 0.55. 1 minus 0.55. 2 minus 1 minus 0.55. 1 minus 0.55. 3 minus 1. Right? After you calculate, you actually get the answer 0.0911. Finally, we want to find for the expected value of x and variance of x. Right? So, for our expected value of x, if 1 divided by p, probability of success, that means 1 divided by 0.55 equal 1.82. Or we can say 1.8182 if you want to be more precise. And then we get the variance of x equal to probability of failure 1 minus p divided by probability of success squared. It means we get 0.45 divided by 0.55 squared, but we will get 1.4876, and that is your final answer.